Interior angles of polygons. So just to start off, convex polygons are polygons that have shapes going outward instead of inward. A or a concave polygon would look something like that. It has a piece that's going inward, and it also has measurements that measure larger than 180 degrees. So whenever we're talking about convex polygons, this is what's happening. And the reason that this is defined is because we're talking about triangles. Triangles make up polygons. So whenever we're talking about how many degrees are in any type of polygon, which is a shape with many sides, then what we're going to be doing is dividing it into triangles, because we know that triangles, every single one of them has 180 degrees. There is a formula. It's going to be the number of sides of the shape minus 2. That is going to be what we're going to be multiplying by 180. So whenever we're dividing this up, we know something has 5 triangles in it. Cool. Then we're going to be multiplying those 5 triangles by 180. That's how many degrees are inside of that polygon. It'll make more sense once we start breaking it up. So just an idea, we have 1, 2, 3, 4 sides on this polygon. And what we did here is we took 4 from this rhombus and we subtracted 2. Because whenever we're going to divide it into lines or into sections of triangles, well, if there are 4 vertices, we can only connect 2 of them, leaving 2 of them not connected. And you'll see that on every single shape. So that's why it's minus 2. And what that's going to do is it's going to create triangles within the polygon we're looking at. So let's go ahead and just take a look at a couple. So you can see here is a rhombus. And what we can do is we can go ahead and just cut it in half. We know that there's going to be 4 sides. So it's going to be 4 minus 2 equals 2. That is going to equal 2 times 180 degrees, because we have 180 degrees here, we have 180 degrees here. That will give you a grand total of 360 degrees, which coincides with everything that is a quadrilateral. All quadrilaterals have 360 degrees, and this is why. They're made up of 2 triangles. Or triangles are made up of from half of its quadrilateral that it came from. So a lot of the volume formulas for finding volume of 2-dimensional figures, they provide a better explanation as to what quadrilateral the triangles are coming from, because there's many different types of triangles as well. So we have 1, 2, 3, 4, 5, which would make this shape a pentagon. So number of sides, 5. So n is going to be the number of sides. So 5 minus 2 equals 3. And you can see whenever we are going to take a line right here, and we pick a vertex, if we drag it out to each one of them, you can see it only makes 3. Now, if I were to keep going on that vertex and I'm going to this angle up here, that's one of the 2 that we're subtracting, because it's not going to make another triangle. So whenever I do this, it's going to be 3 times 180, which should be 540. So there's 540 degrees in every single pentagon. 1, 2, 3, 4, 5, 6. And we can do the same thing over here. And you'll notice that there are 2 vertices that are not used. That would be this one right here and this one right here. And it depends on which vertex you choose, but there will always be 2 that are not used. See, look, there's 2 here that were not used. There were 2 here that were not used. And that's where the minus 2 comes in. So you can see that this is going to create 1, 2, 3, 4 triangles. All right, so this is a hexagon. It's got 6 sides. So 6 minus 2 equals 4. So I'm doing 4 times 180, which is going to be 720. So we know that all hexagons have 720 degrees. This is how we break down how these polygons are working and how many degrees are inside of them.